Solving a system of equations by the substitution method is very desirable, especially in many of your science courses. What is particularly nice when you use this method is if one of the two equations that you're getting ready to use has one of the two variables, x or y, and it could be v and p in a chemistry class. If one of the two equations is already isolated for a variable, for example, here's my first equation in the system and here's my second equation in the system. This second equation has y all by itself. Y equals 2x plus 1. When you use what's called the substitution method, what you do is you take a portion, or you take a value, this is an expression, y is equal to this expression, and you substitute it into the other equation. So you really want to use the substitution method when it's easy to isolate a variable, number one. So I isolated the variable y and it's equal to 2x plus 1. And you must substitute it into the other equation, not into itself. That would be a big mistake. So I want to put 2x plus 1 in for y here. I'm going to go ahead and take it over here and do that. So I have x plus 2x plus 1. X plus that 2x plus 1 equals that number 4. And now I'm going to solve for the single variable in this equation. So this 1x and that 2x combines to be 3x. And then I'll subtract 1 from both sides. And finally, I'll divide both sides by 3 and find out that x equals 1. A system of equations that is in two variables has both an answer for x and for y. I have the answer for x right now. I need to substitute that back into one of the two original equations to find out what y is equal to. I'm going to choose to go into this version of this one of the two equations because it will be easy to solve for y by substituting in for x here a number 1, and then this 2 plus this 1 is equal to 3. And I have my solution set, which is includes x is 1 and y is equal to 3. I should take those values and substitute them back into the original equation. I'm going to go ahead and do it for this one, but I'm going to erase some of my work to do that. So here's my solution set. I'm going to go into this expression up top, and I'll go ahead and take out this work right here. So I'm going to go right here and ask myself, if x is 1 and y is 3, and I substitute that in, is that a true statement? And it is. Down here, if y is 3 and x is 1, so right there for x I'm putting in a 1, do I get a true statement? And it is. It's very nice. You can walk away saying, I know I got this solution correct. Let's do one more using what's called the substitution method. So we've already solved graphically. We're going to see if you like this approach a little bit better. So one of my equations is going to be y minus 2x equals 0. And the other is going to be 3x plus 7y equals 17. So I have to decide if I want to use the substitution method to choose to take either this equation or this equation and solve for one of the two letters. It is easiest to solve for a variable that has a 1 in front of it. Because in this particular case, I'm going to go ahead and take this over here, y minus 2x is equal to 0. To get y alone, all I have to do is add 2x to both sides. Now, 2x, this right here, which represents the letter y, can be substituted in for y in the second equation. So I can put a 2x in right there. So I'll have this 3x plus 7 times the 2x, which is y, and I'll solve that statement for x. So I have 3x plus 14x, which adds to be 17x. And then when I divide both sides by 17, I find out that x is equal to 1. Now, quite simply, while this is not one of the original equations, I'm an advocate of, if I feel confident in this work right here, that I added 2x to both sides, I'm an advocate of just going ahead and saying, well, y is equal to 2 times whatever x is. So y is 2. And so my solution here is x is 1, y is 2. But if I chose to do that right there, I will go back to the original equations. Please, the original equations. I'm going to get rid of my work here now. I will take those and substitute into these two statements those values to see if they work. I'm going to do that real quickly. So y is 2 minus 2 times 1. So does 2 minus 2 give you 0? Yes. And here, x is 1 and y is 2. And does 3 plus 14 add to be 17? And it does. That's a good look at the substitution method. Again, you're going to have to decide if you like isolating a variable and substituting what it is equal to into the other equation and solving for a single variable. Once you have that single variable, in this case I think I found x was 1 first, substitute that into one of the original equations to find the value for the other, in that case y.